A very warm welcome to all of you. Good morning, good afternoon, or good evening, whichever part of the time zone you're joining from. And to all my dear Indian friends, Namaste. Most of you would be battling a midweek crisis at office and a session at 6 p.m. right after office. I can totally hear you. But let me promise you, you're going to witness something happening for the first time inside a PowerPoint presentation. But before that, let me introduce you to today's session, Navigating the New Normal. What do you think is the new normal? The pandemic? No. Work from home? No. Digital transformation? Maybe not. In my opinion, the new normal is moving from data to insights at rapid speed and scale. In today's world, it is imperative that the companies who succeed are the ones who are moving in this direction. They move from data to insights at such a speed and scale that they are able to deliver creative solutions to the business problems. And today, we are going to look at a tool that is a stepping stone in that direction. But before that, here's a small disclaimer. This presentation is based on my personal opinion and does not have any connection with my employer, employees, KNIME, or others. And with that, let me introduce you to KNIME. KNIME is in the market for the last 15 years. They are headquartered in Zurich and also have a branch in Texas. Their brand promise is open for innovation. And KNIME Analytics Platform is an open source, low code, no code data analytics tool. And the best part is it is completely visual and intuitive. A short video on that coming your way shortly. And it also has so many nodes through which you can do any task that you ever wanted to do. And the USP of the tool is all of this happens with a click of a button. But before, do you remember, I told you that you're going to witness something happening for the first time in the PowerPoint presentation. Can anybody here imagine what is your most favorite aeroplane? The first time you saw it, how did you feel? Well, for quite some time, I've been boarding this plane very frequently. And you know what is the best part? It takes me from data to insights so quickly and reliably every single time. Just like how we had our Lego blocks when we were young, we used to put everything together and build a castle. Similarly, I use something called as nodes to build a workflow and get my job done. There are nodes across data ingestion, for data transformation, for data analytics, and of course, reporting. We'll look at all of this in detail and how you'll come to know shortly. Let us now see a short video so that you get a look and feel of the platform and what are its capabilities. So this is the user interface of the KNIME Analytics Platform. On the left, you have all your nodes. You can just pick them and drop them into the workflow editor and create your workflow. I mean, just look at the speed at which you can create a workflow. Amazing, isn't it? Whether you are a functional guy or a business guy, it doesn't matter. All you have to do is just drag and drop them. And that's not all. You also have to configure them according to your requirements and the job is done. All of the workflow is executed. And this is your KNIME Hub, where you can see the many workflows that have been created by KNIME and other users as well. This can be a great starting point for users who are using the KNIME tool for the first time. And this is an example of a guided visualization, where the results are visualized using various different types of chart. And here is an example of a sunburst chart. So with that, we come to the end of this video. And you remember, we landed a plane right into the presentation. So where is the plane going to take us? Any guesses? Well, we are going to go on a KNIME tour across 4 pit stops. And like every trip, we have some goodies in store for you at the end of the trip so that this tour is very memorable for you. Our first pit stop is an example of a payroll processing and how KNIME changes the dynamics of it. I'm sure most of you are already thinking about the notification in your mobile phone for this month's salary. But let's see what happens behind the hood. Typically, a payroll is a time critical process. You have a deadline which you cannot extend or exceed. And there are a lot of manual interventions in the process as well. So the process typically starts with payroll input files. One is an employee master and the other contains details of the salary components, days the employee has worked, and the deductions that you have to make. So when you combine both of these files, you get the payroll input file where the salary is computed. So once this is done, you send a payment advice to the bank to credit the salary to the employee's account. And on the other hand, you also send a pay slip to the employee where he can see the breakup of his salary for the month. Let's now see how this can be automated using KNIME. So here we have two files. One is the employee master and the other is the payroll inputs. We are using the joiner to combine both of these files. And then using a node called math formula, which is very similar to how you apply formulas in Excel. You are applying all the logics, like first you are arriving the gross salary and then the net salary and then number of days the user has worked. And then you multiply all of this to get the salary payable to the employee. And at the end of it, you're also verifying if your computations are correct. And then you're sending an email of this to the bank. Email, yes, you heard it right. From KNIME, you can shoot out emails of Excels and PDFs to whomever you want. And that's not all. You're also creating a PDF of the breakup and sending it to the employee as well. Let's now see how the output looks like. Mind you, all of this is happening within KNIME Analytics Platform without ever opening an Excel file or a browser. How cool is that? But it doesn't stop there. KNIME also has advanced analytics features. You can use the time saved to develop your people strategy. Just imagine if you can combine your origination, your retention, your attrition with your payroll data, you can completely recalibrate your people agenda. Wow, that was just the first pit stop. Do any of you remember what the second pit stop is? Yes, of course, it is marketing, a field that never fades away, but in recent times has changed dramatically. In the current world, most companies are employing a phygital model of doing their sales and marketing. So what is happening is a lot of data is being gathered about customer behavior, which could be analyzed. But the problem is integrating machine learning into such large amounts of data and deriving insights at speed and scale becomes cumbersome. And here you have the typical customer journey process. So either it's a physical model or a digital model, and you have a lot of data gathered which needs to be analyzed, and a machine learning model needs to be built, deployed, and then whether you are a business user or a data scientist working in any company, your motive is to achieve higher sales, right? But how exciting would it be for you to see this whole journey automated and happening in just the blink of an eye in KNIME Analytics Platform? You're just going to be seeing that. Here in this workflow, we are using a k-means clustering. All of you data scientists out there, I know you're already excited to hear the word k-means clustering. So before that, we are also using a normalizer node so that whether it's 10 or 10,000, the model considers both of the values without any bias. And then we are visualizing this so that we can derive tangible outputs from the data, which is called insights. So I hope this workflow is clear. We are having an input data, we are joining it just like the payroll node, and then we are using a k-means clustering algorithm. Oh, wait. You're wondering, Vivek, where is the code over here? If you remember, I told you KNIME is a no-code and low-code platform. Everything happens through the nodes. All you have to do is just configure them and boom, your work is done. So this is the end output. What can I get out of this? I'm not able to understand. Well, that's where insights come in. So if you look at it, these are the price sensitive customers whom you can attract further by giving discount coupons and making them move to the higher tab. And next, these are your premium customers who are affluent and already spending a lot of money on your products. So you can focus on moving them even further up the ladder by using attractive advertisement campaigns or offering them hyper-personalized solutions. But the interesting thing is the customers who have not fallen into either of these two buckets. If you look at it, the work of the K-means clustering algorithm was to segment the customers. So if you clearly see, we also applied a color code over there so that the segments are clearly differentiated and we could derive these insights. So what do you think you can do to the customers who are there in between? Do let me know when we meet at the board outside the main conference hall. I would love to hear your inputs, and the most interesting ones stand to receive something from me. All right. So now comes the next bit. So something that is very close to me because I also work in finance. Finance is considered as the lifeline of every business, but it takes the life out of every professional who does consolidation or reporting. And why so? Because it's completely manual and the logics are complicated. And the legacy knowledge that is usually inbuilt into these Excel workbooks become very hard to transfer. Mistakes in a single cell can stall the entire process. So now let's look at a typical consolidation or reporting process. A user inputs the data into an ERP which gets posted at a company level. And then you kind of have to do a data analysis and consolidate this data so that you can present it at a group level, or you just have to analyze the data and present insights to senior stakeholders at the company level. So this whole process, which is usually done manually, can be automated in KNIME. So all you finance users out there, are you ready to see how this could be done? Well, here we are building a workflow on top for the analysis part, where we are using an Excel reader node, and then we are consolidating the data at a group level, and then using pivoting, math formula, and then a few data transformations, we have our output perfectly ready. And next, we are pushing this output that we have into Power BI, and that also happens within KNIME. Phew, too many goodies already in store for you, but there are more coming your way. Please hold on. Let's quickly look at the output so that you're able to correlate what I just told in a visual form. So the data usually looks like this. In terms of rows, there are so many rows, so many complicated data points. And the output of the first workflow is on the left-hand side, where you can see that we have clearly arrived at the income statement. And on the right side is a Power BI dashboard. So this whole process is automated within KNIME. So is my job done? Well, that's where things get interesting. Because we are moving away from a concept of financial planning and analysis to extended planning and analysis. It helps drive finance to be an enabler of business transformation through strategic decision making. And how does that happen? Through what-if analysis, scenario-based decision making. And mind you, this is just a bird's eye view of what is possible. With KNIME Analytics Platform, you can achieve all of this and more at speed and scale. And now we are going to go and stop at our last pit stop. Can somebody guess what it was? Well, supply chain management. The moment I think of it, the likes of Amazon, Walmart, and Flipkart come to my mind, whose business thrives on effective supply chain management. The idea behind an effective supply chain is to ensure that the right product is available at the right place and at the right time. Today, with the power of analytics, it is possible to be prepared better by forecasting your requirements. Can be on the demand side or the supply side. Let's just look at a typical process. You have a certain requirement and you need to know how much material or quantity of anything that you need at a particular point in time. So you review your historical data and then you forecast using an AI model and then you place an order. But before that, while you create your purchase order and it is submitted to the supplier, there are also a lot of validations and internal checks and balances that you do to ensure that the material requirement that you are requesting for is actually accurate. So once that's done, the request is raised and boom, it goes to the supplier. This process is obviously marked by a lot of manual interventions as well. Like there could be wastages if your forecasting is wrong, a lot of manual analysis if it isn't automated, and there are also time constraints that you have to meet because it could result in disruptions. Oh, when I say disruptions, do you remember of the recent cell shortage? Or before that, the semiconductor shortage? Or on the demand side, you can think of COVID when the sanitizers and masks demand shot up abruptly and people were not able to manage their supply chain. With integrating AI, it could be possible to better forecast your supply chain requirements. Here in KNIME, we are using an auto Sarima model. Oh, again, the data scientist out there, I know that Sarima model is considered one of the most complicated model in machine learning. But here in KNIME, the whole node is completely automated. All you have to do is just configure it. I don't know anything about machine learning, but I was able to forecast the demand for a particular requirement using this node. So if I can do it, anybody can do it. But before that, once we load the data, we are removing numeric outliers so that our prediction is accurate. And we are also replacing missing values with relevant values so that our output is not distorted. So the auto Sarima model has run. How is the output going to look like? All numbers? You got it wrong. It's completely visual. If you look at it, here you can see the black line is what we have, the historical data. And from here on is the forecast for the next 30 days. Amazing, isn't it? How cool is that? Well, I think it's absolutely cool for someone who has no knowledge of machine learning to develop a graph like this based on an auto Sarima model, and that too within a few minutes. And all the supply chain gurus out there, I would be keen to hear from you. What do you think KNIME Analytics could be used for other than the use case that I just showed? I'm very keen to hear from you. Please do meet me and let me know what you think. So with that, we have come to an end of this tour. And in a nutshell, this slide represents why KNIME can be your preferred data solution. It integrates with all the existing solutions that you use, yet makes your life so much simpler. This slide would be available for you to download and reuse. So you don't have to worry if you're not able to ingest this image right away. It basically says the nodes that are available under each area and how it pans out in the big picture of going from data to insights. Like I always said, speed and scale are the mantra for success in today's world. Let's now look at what are all the integrations that are built into KNIME. You have Amazon, AWS, Excel, a Twitter API data request node, and H2O node as well. Oh, wait. For people who got offended when I said KNIME is purely a no-code, low-code solution, don't worry, you're covered. If you do want to write code, you can always use the R or Python node to integrate your code into KNIME. So KNIME welcomes everybody to be a part of it. It's not just built for people who want to use it as a no-code, low-code solution. And that's not all. We also have a Power BI and Tableau integration. So once your data transformation and data analytics is done, you can push the data directly into Tableau or Power BI using KNIME. Wonderful, isn't it? But like I told you, we want you to make sure that this journey or tour that you had with me is very, very memorable. So we have placed a few books in the library section of this map. So if you do go there, you can use the code DC India 0722. I repeat, DC India 0722 to download these books. You can download them absolutely for free. Usually, you have to pay money to get these books. So since you're all attending the Data Connect event today here in India, we are offering all of these books to you for free. And with that, we come to the end of this presentation. Thank you for being on board the 9747 airline. And always remember, the journey of 1,000 miles begins with the first step. So if today is your first time knowing about the KNIME tool and you have any sort of basic questions, please feel free to reach out to me or any of the KNIMers in the map. All of us would be happy to help you. But before I conclude, I would fail in my duties if I don't thank Team 9 for giving me this wonderful opportunity. Over the last 1 month, I've spent a lot of time thinking of how well or how could I reach out to the audience better. And in that process, Mr. Mahantesh from KNIME co-worked with me and we were able to arrive at this beautiful presentation. I once again thank Team KNIME for giving me this opportunity and also for all the excellent support provided. But hey, I do have a request. We would love to see more of physical events in India where we can interact with people and learn from each other. Thank you once again, and I hand over the virtual podium to my friend Girinath, who will be presenting next.
Hi everyone. I'm much excited to connect with all the known and dear ones, basically. So greetings to everyone from different parts of the world, and good evening to India. So Vivek have already given a good introduction about KNIME, an overview about the interface, as well as in marketing, finance, and supply chain. I'll be going a bit little more into life sciences and drug discovery. I'm not sure how many of the attendees here are into life sciences, taking chances moving forward. So myself, Giri, I'm a senior scientist in computational chemistry division at Signature Discovery and recently moved to UK. And I'll be talking about the KNIME life science overview, the data visualization, how to generate data within KNIME, KNIME in drug discovery, a few case studies and quick demo if time permits. By the way, to be a little more technical, but we can always discuss because some of the nodes that can be, which I'm going to talk about in data generation and data visualization, could be used in many other factors in applications too. As a disclaimer, all are my personal opinion and does not have any connection with my employer, colleagues, or others. Most of the slides contains content, pictures, videos taken from web articles, pictures, tutorials, even from KNIME course materials, because it's easy for you to refer something and you can pick things up from there. And that's the reason I have taken the data from there. And if you wanted to work on some of the workflows that I've uploaded, you can go to Hub KNIME with most of the social handlers, Giri Bio. You can get the technical slides, much more others also from these links which I have shared in this website. Of course, this is already there in the slides that you can download. Both myself and Vivek's slides could be downloaded. So just to do a recap on the KNIME Analytics Platform, of course, KNIME works with workflow, and you can do analytics, reporting, as very wonderfully Vivek has explained about it, and you can also automate. That's a part where we are looking at. More of integrations and parallelizations could be done. Parallelization in the computation as well as in the processing. And you come up with a very intuitive interface, which is very easy to understand and also plug and play. But you need to understand there are certain kinds of input node, output, basically ports, basically called, and this partition that's called as a node. And then there's traffic lights for that. If the traffic light here at the bottom, three of them, it's red, not configured, then configured, executed, or error. This gives you an highlight what is still required for the node or the process to complete it. And then you can have a very big workflow which can be completely automated, which you might be doing currently manually one by one based upon the output and analysis. Now, there are different, as the same traffic lights I'm showing you just in a different node, how it looks like. If you're looking at the interface recap, as I already told about nodes, you can configure them, parameterize them, and memory policy can be also defined, including flow variable. These are slightly advanced, but it's going to help you a lot on some of the nodes that I'm going to discuss further, especially on the loop and chunk. So workflow editor has nodes option. You can annotate them. You have like a description for each of the nodes you're giving. So try to spend some time initially on the KNIME tutorials, the videos, as well as on the learning materials. That is going to help you a lot. Generally, we are always happy to start working on it rather going through the documentation. So I would recommend slightly get into those case studies. There are a lot of case studies there out there in KNIME website. When I started using KNIME back in 2009, the materials were very much limited. The notes, very few notes, which is very handy. Still, back then it was very useful. But now it's the ecosystem has enlarged with a lot of community providers, including training, nodes, extensions, and many more. And then you can also drag and drop just the nodes towards the workflow. Similarly, you can also customize them or parameterize them or configure the specific nodes as and when whatever you wanted to require, how the node to be executed. Similarly, if you want to run a single node, you have to use this particular, the green colored play button. Otherwise, the multicolored play button to be used for running all the nodes. And this is something the best practice we have to be, as I can say, SOPs. It's recommended for sharing or if you're trying to switch between the workflows between different OS. This is where you have to take care of workspace relative path. Generally, when you try to take out or pull out Excel sheet or CSV files or specific data into KNIME for analysis, it will also take your path. Basically, maybe documents or desktop or downloads or specific folder directory will be taken. But when you share it with your colleague or with a different OS, the directory structure is exactly completely different. So, but still the file name might be same. To overcome these issues, or even when you're uploading workflows to Hub, so it's better to follow the relative path. So rather than using the normal directory structure in your operating system, you can go for a relative path either by choosing current workflow or current workflow data area. By default, read from will be like local drive or local data that you can change it to relative to, and you can make it to workflow and put your data within the workspace directory so that you put it in any workspace in different computers or different operating system. They seamlessly work without any no file not found or directory not found issues. Now, looking forward to KNIME in Science, it's very important to know you have to install the extensions and nodes for drug discovery, bioinformatics, and data analysis. That mainly comes from community extensions, which is like bioinformatics and NGS and chem informatics. There's a simple trick that I want to tell you is that there are some experimental nodes available, and some of the life science nodes are available in experimental. So I'm being experimental means they're still in the working. It works well. I used to use that. So, but it is until unless you enable the experimental source of installing the software, it won't show up. And I want to give a tip from my side, which I have been used to do it always. Whenever you're working on drug discovery, life science data, we are playing around with huge number of data. KNIME might not require too much of CPUs, but KNIME requires a lot of heap space, basically when you're using large data. So many a times when I'm pitching KNIME to life science community, they used to tell me I get some error, it is not finished or something. It's just because you need to increase the heap size. Even if you're having 4 GB, absolutely fine, but make sure you increase the heap size, all will be well if you're handling some large data set. Some of the life science node extensions you can, if I get segregated as cheminformatics, bioinformatics, mass spectrometry, or even HCS like high content screening, or other virtual screening can be also taken like HTS also. So if you're looking at drug discovery names, whatever I have highlighted here, these are freely available NIME extensions and nodes. Some of them are free only for academics, not for commercial. So please look into the licensing terms and conditions to make before you use it. The next set of extensions, what I'm shown here, they're all paid. That means you should have respective licenses from the provider, then only KNIME can make use of those particular nodes and its calculations. So if you're looking at few extensions of the cheminformatics and CAD, you have plenty of them from 3D eChem, Earlwood nodes, RDKit, even CDK. So back in 2009, there was only CDK started, and later the Indigo, Earlwood slowly came in one by one, and later RDKit came in. So it's a long journey how it got evolved in this ecosystem. And when you look at the commercial extension, as I said, you need to have the commercial license. You have Schrodinger, Biosolve IT, Chemaxon, Cresset, Mono, and many more others. If you're looking at the data management in the life science, this is something very important, not only in life science, in many other field or in applications. I'm not taking out all the nodes here. I'm taking very important ones, which could be really helpful, which we used to do in Excel by writing functions and a little bit on the round. It's not straightforward. So I'd like to introduce two nodes in this slide. One is joiner and the other is group by. Group by is like an operation involves some combination of splitting the object, applying a function, and combining the results. For example, if you look at this table, you have row ID, group, and value. I want to combine or summate the particular rows, and then which is under the group N, and I want to take the sum value. It's very easy to do when you're going to use group by. And you can do manual aggregation, pattern-based aggregation, and type-based aggregations can be done. So you can collate or combine or split based upon function of those different data that you're going to load them. Joiner, it's a way that you can remove duplicates. You can have an intersection or a union of different data that you're going to combine from different sources of same data type, which is very important because the columns should match each other. Then only they will try to see whether it is matched or unmatched. All the data you come out through joiner. And it's kind of a dynamic node. You can increase the number of input ports. Right now I have only 2 ports here. As you can see, one coming from Excel, the other coming from table, but you can have 3, 4 based upon the need. You can increase them. Looking at pivoting node, again, very interesting node for data wrangling or data manipulation, you could say. Basically, to summarize the data again, aggregation of column, operator, groups, and pivoting them. So they performs a pivot on selected columns for grouping and pivoting. Can be used for values of group columns, which becomes unique rows. Values of pivot columns becomes unique columns, or many aggregation methods are also provided, including sum, count, percentage, ratio. For example, if you look at the bottom table, the store, you have a group product ID, which is 123G123, then store online, and then category and ordered items. So the store is going to be the pivot, whether it is online or on-site. And the category is going to be my group, whether it's a group of the books to be grouping as books and compounds or PC. And ordered items is going to be the aggregate. When I'm going to aggregate or pivot as a sum is in being ordered, I can say the group is where the category comes, like books is a group where I can see 7 online being completely ordered and 1 on site. That is aggregate. So that's how the data got transformed. So you can select a specific column to grouping and pivoting. And there are 3 different sections in configuring the pivoting node, basically like groups, pivots, and the aggregation. So you can define the function. You can completely parameterize it. So that's the advantage of while you're going for pivoting. Then Pareto ranking, very important in predictions, modeling, as well as when multiple properties comes together. This is called as multi-objective optimization, or in drug discovery, we call it as multi-parameter optimization. Let it be anything you design, a product. It could be a drug that you're designing, or it could be any other product that you're designing. It can be only improved using modeling, simulation, and optimization techniques. You go on optimizing it. You go on iterating it. The optimal design is a measure of what is good or desirable about a design. So identifying the specific characteristics or properties or parameter which contribute the most to the overall value of the design to be identified. So good design typically involves multiple criteria and objective. Just considering one property, you cannot think that the design is perfect. And that's where the multi-objective optimization node that is called Pareto ranking is going to help you a lot. So here I have used log P, polar surface area, molecular weight, hydrogen bond donor, acceptor, and stereo senders. I can set a range, minimum and maximum, optimal range, whether it should be more minimum or more maximum. So based upon that, the node will be able to prioritize which compound is having all these properties optimally. It's not only about compounds or drug design, it could be applied in any other field. Now coming to very interesting node, which is called loop, where you can automate with a lot of functions and conditions. You have loop start, you have chunk loop, group loop, recursive loop, loop end, loop column, and parameter optimization loop. One of my favorite is loop, chunk loop, as well as parameter optimization. I'll tell you why chunk loop. Chunk loop is basically send subset of data in each iteration, but it can also do a CPU-based parallelization. So when you go for computational chemistry or drug discovery, you might be having lots of data which you might load for docking, screening, confirmation analysis, and all. Single CPU gonna take ages to finish. So chunk loop will help you to parallelize. So if you have a 8-core machine in your laptop or computer, I can do the chunk loop and say 8, and it runs on 8 CPUs parallelly. I've been using it regularly. And the last one, parameter optimization loop, which again, you can parameterize it. For example, when you're doing a modeling, you wanted to know based upon a specific score criteria you give. I need accuracy, maybe like greater than 92. So I want it to be parameterizing based upon what features you are going to select. So I'm going to optimize the loop saying that based upon these criteria or condition, try to parameterize until you get the model with accuracy of 92. So parameter optimization is also good. It takes more time. That's what, if you need more accuracy, more optimization, takes more time, but it's very valuable data mining process, and it does automatically. So that's why I said it's very lovely, wonderfully does the automation part. Now, when you look at the data analysis in life science, Vivek already showed you some of the data visualization nodes. But to be specific on life sciences, I mainly use JavaScript-based visualization nodes, including some of the nodes that comes from Chem Informatics, basically from Vernalis and Enwood. They have some of the scatter plots which are really good as per the need of a ComChem scientist. So they are web-based and interactive. They are similarly integrated from an external library, and you can also do scripting-based like R or Python-based view visualization nodes. They really do a great kind of analysis that you can do from these plots. But something that is related to life science is something that you can look here, the parallel coordinates plot. And based upon the assay, you can take the mean log. If you're looking at the structures, of course, you can also have an interactive table versus the the visualization plot. So if you select something on the plot, it also notifies in the table, yeah, these are the compounds, or these are the data points that you have selected. So these are much interactive and they talk to each other. When you look at the case studies, when you're looking at machine learning data in drug discovery, I want to tell some background about drug discovery. The main and importance of computational studies or data analysis or data science in life science or drug discovery is because of the cause of failure mainly. We wanted to identify why it is failing. We want to overcome that. So basically, when you look at between 1960s and 1980s, most of the drugs failed just because of poor pharmacokinetic and ADME properties, including efficacy. But to some extent, we were able to overcome in late 1990s based upon predictive models. Of course, we were using machine learning earlier then too, using like support vector machines, random forest, or ANN. But we never hyped saying that it's machine learning. Rather, we said it's a statistical method. Right now, the era is that even if you do statistical method, we say, I did machine learning. So make sure we position them in the right place. But between 2000 to 2010, we realized that we were able to overcome the challenges with the poor ADME properties and efficacy, and the cause of failure has turned down to something else. That is because of toxicity and the strategy. So now we need to come up with a different model where we can overcome these challenges. That's where the design comes in. That's where the optimization comes in. So the chemistry data used in machine learning, we need enough data to train model. And that's a challenge that we have. We do have enough data, but we don't have the right data to train the model. We cannot simply put every data from here and there to put together to make a single model. There are certain criteria, there are certain conditions to choose what kind of data that can be used for training the model. Experimental optimization, even understanding the historical failures and success of reactions, and you wanted to optimize what kind of reagents, conditions to be used for better yield, better purity of the compounds for better testing. When you're looking at machine learning and deep learning applications, especially in chemistry, physics, biology, life sciences, you have many things to do, but make sure you have the right data to start with. You have no code algorithms and programs to help you out to model them, but make sure you have the right data. So since we do not have enough right data for AI in drug discovery, of course, many companies are there, AI companies in drug discovery, but they're investing a lot of amount for generating the data. So generate the right data. The question is whether it's going to be experimental or whether you're going to use predicted, quantitative, or qualitative. Now let's do not complex it. Let's make it very simple. We'll go for the predicted data right now. Now, how do we generate the data? That's a good thing I like with KNIME as being evolved like anything. You can generate the data within KNIME itself, especially on life sciences. For the predictive data, keep that in mind. So we need some language that machines can understand, which is the data for chemistry, that is the fingerprints. So we convert the chemical information to fingerprints. When you look at the basic chemistry nodes, we need readers, file readers, opening files, certain different file formats, writers, sketchers to draw structures and view the structures even in 2D or 3D, even pharmacophore interactions, everything can be done with set of nodes. Don't worry, you have the slides already available. You will be able to download all these slides. And then chemistry calculators, we need to calculate properties, right? We need to generate data for modeling. So we can generate partition coefficients like log P. If you're interested for penetration and other bioavailability, you can look at log D, then log S for solubility, and many more other molecular properties and derived descriptors and many more from different providers is possible. NLOs is from NIH, but works only for Windows, not for other platforms. That also generates a good amount of properties. And when you look at the chemical format writers, keep this in mind. The data types are very important. When you're trying to do some modeling, like ML modeling in KNIME, certain models or algorithms require your target to be defined as string. By default, if it is being defined as integer or double, it will not run. The node will alert you with an error. So make sure that you define it as a string. So here you can see yes is for string, then you have I for integer, So make sure that you analyze when you load your data itself from the beginning. Otherwise, you're going to waste your time, and at the end, you find the error. So these are things that you have to take care. Some of the case studies that I want to mention very quickly due to short of time and interest of time. These are being already uploaded to Hub 9. Not so much exhaustive, very simple ones for people to get into KNIME, or a beginner or an intermediate level who wants to use KNIME and start and make their life easier for automation. So what I have done here is that you're taking a CSV file or with smiles or mole file or SDF files, and you are able to find out confirmations, or you're able to convert from 2D to 3D, either based upon force field based or molecular mechanics based. You can choose what method you want. Then you can predict certain developmental toxicity models like using Vega. Keep in mind, Vega is only available for academics, not for others. So you need to have an academic email address to get access to Vega nodes. So these are also able to predict mutagenicity, carcinogenicity, developmental toxicity, skin sensitization, and many more toxicity data can be predicted. When I was in academia, I used this, and you can see it is 2018 where I have developed this workflow. And you can also generate the confirmations. All the drug discovery scientists knows that low energy confirmation has its own important role in identifying the bioactive confirmation where it binds to the biological target. So we will be able to find out the low energy confirmation using RDKit based upon force field confirmation energies. And you can do a substructure similarity search. Again, this is a bit old workflow. The current version does not have similarity viewer. One of my favorite node, but it works only with the old version of KNIME, not with the latest one. You can do a matrix, heat matrix, where it does the structures can be compared within the data set, different data sets. So you can load all the PubMed into the SDF reader, and you can draw in the Marvin sketch a substructure or a R group, and you will be able to do a search offline. I know you are doing it online, but when we are working on confidential structures, you need to do it offline. And that's when KNIME is wonderfully works, seamlessly nice. But make sure that if you're loading a lot of data, your heap size of the KNIME is being increased manually by you. And you can also do pharmacophore-based screening. Again, shape-based or interaction-based screening could be also done with a plants extension node provider. And you can also do a multi-property descriptor, molecular property descriptor, especially used for SAR analysis and MPO. The providers are like CDK, RDKit, Indigo, NLOS, XLOCP. And recently, if you're in KNIME, you can also integrate with Python. So you can use PyPedal and Modred. Make sure you have used Anaconda or Miniconda so that all the dependencies are installed. So PyPedal uses a Python-based library for Pedal descriptors, and Modred is also very well scaled up for multiple structures to calculate the descriptors. And this one is being for extracting Campbell data. Recently, there was one of the life science event from KNIME where many of the speakers from the pharma industry spoke about, and there this particular question came up to retrieve the data from Campbell. Of course, there are KNIME nodes available for Campbell lookup, but if you want to more customization, you can go with the JSON and string manipulation for RESTful API. It still works. When you have a large amount of data, of course, you need to have a good RAM setup so that it will be able to still pull out the data. So that's how it works. A lot of customization can be done with extraction from the model. Now, machine learning can be applied everywhere. Similarly with drug designing too, especially on SAR analysis and prediction of properties to design the molecule. The choice of parameter optimization is completely depending upon the data that you have. So you need to know what you're doing. So naive Bayes or logistic regression, random forest or XGBoost or AdaBoost, whatever you're trying to do. I like the fact that there is something called as AutoML from H2O as well as from KNIME. I use it regularly just for an initial run to see how the trend is. It takes some time, but it seamlessly gives wonderful results to have an idea about even feature selection workflows to understand which of the descriptors are having more importance correlated to your target. And then we compare the model performance and pick the best one, build and deploy the best model, and create the model report. So there is something called as PMML node where you can write and create the model for new molecules. You will be able to design them. If you're going for a web-based interface, you need to have a server, KNIME server, to perform those kinds of calculation. Very simple workflow that if you already have a CSV file with the descriptor values, properties of the compounds and its target, that is activity data, and then you can do it in the partitioner node. It will partition into training set and test set, and the training set goes through the random forest learner where you can parameterize there, and then you can give the random seed or you can define the seed values, and then the predictor takes the test set and the training set to predict them, and again you can run it through linear regression, and again you can aggregate them and plot it in scatter plot using plotly or others. And similarly you have other where you can do filtering of the column can be done. I used to do feature selection filters where there should be a model to use feature selection filters, and then you can partition accordingly where you can use a loop node in order to parameterize it automatically, so that we are using a scorer node to tell us that until unless I reach this particular score, you go on optimizing it different range. So I give an example. Let's imagine I want it from 5 to 8. So it will try from 5, 5.2, 5.3, 5.4, automatically does it. I need not to do it one by one. So those loop nodes are really important if you want to parameterize at different parameters. Those models can be done there. And there are a lot of training videos for that, so I need not to do that here. So I would recommend you to please go to KNIME docs as well as KNIME learning website, where you can have all these videos very well explained. Some of these links are already given here. And that's all from me for today. I would like to thank my director and line managers at Signature for permitting me to interact with you and network with you and share my small insights about life science applications with KNIME. And I also thank KNIME and the team like Polo, Rosario, and many others, including Stephen and others who are already here, and coordinating with Mahantesh Monty, who was being interacting for the past 1 month very closely. And kudos to all the team for the Data Connect India. Thank you so much.